When you think of feet, you think of walking, but specifically on land, right? What if I told you that's not always the case? Well, sometimes. You see, some organisms have also evolved to have the ability of walking on water. That's right, folks. You heard it here first. Some organisms do have the ability to walk on water, but that's not all. They can even leap and full-on hurl themselves over the water without ever sinking. How is that even possible? Well, to investigate, let's look at the macroscopic scale, then we'll look at the microscopic scale. Firstly, in the macroscopic scale, you can see a spider with all of its 8 legs on the water, just standing there, as if it was land. And then when we look a little closer at the contact points, you can see dent-like shapes on the surface of the water. And this isn't special to just spiders. You can see this phenomenon within everyday objects like paper clips. This isn't a phenomenon of buoyancy, but instead surface tension, taking our research away from physics and giving it to chemistry. Now looking at the microscopic scale, we will be able to see surface tension at work, doing its wonders. First off, we will need to explain surface tension. Surface tension occurs in water due to having unequal amounts of cohesion on the surface. What's cohesion, you may ask? Cohesion is the force of attraction between water molecules due to their polarities of the hydrogen and the oxygen atoms. To clarify, the hydrogen atoms are partially positive ions that are attracted to oxygen's partially negative anions. This attraction creates these cohesive forces that pull the water together, known as hydrogen bonds. A key footnote to keep in mind is that the polarities of the atoms in water cause most, if not all, the characteristics of water. Due to having these cohesive forces attracting water's surface towards the inner depths of the body of water, and nothing attracting it upwards, the water condenses. It condenses so much so that 1 cubic meter weighs about 1 ton. That's heavier than 14 men combined, while creating a surface that is relatively hard to penetrate, like really hard, allowing insects, spiders, and many other forms of bugs or animals even to walk on water. Another thing that helps spiders walk on water is their hydrophobic hairs throughout their bodies. These hairs try to interact with water as least as possible, making it even harder for the spider to sink into the water. The question of why does this even matter arose to my mind. And after much research, I was able to find that scientists were able to construct surveillance cameras that they would use to place into the wild so they could keep a watchful eye on nature and animals. Furthermore, the knowledge of cohesion and adhesion is vital, and I say vital, to these inventions. Because if they use material that is adhesive, such as glass, meaning that it has a greater attraction force than the cohesive forces of water, then the invention will just sink and be a complete and utter failure, just like my grades. Adam, signing out.